The past 2 years have reignited my unfortunate love for really, really, really bad, trashy reality dating shows. Too Hot to Handle, Bachelor, Love Island UK, Love is Blind, Bachelor in Paradise, X on the 90 Day Fiancé, Dating Around, Singles in Love Island Australia, Love is Blind Married Japan, at First Sight, F-Boy Island. But one of them stood above the rest in terms of both trashiness as well as concept. That show is MTV's Are You the One? I'll let the host Ryan Devlin explain.
If your perfect match was standing right in front of you, would you even know it?
You're here because you have one thing in common. You suck at relationships. Each one of you has been put through an extensive matchmaking process using psychologists, compatibility testing, professional matchmakers, and your friends, families, and exes. Your perfect match is here. 10 guys, 10 girls, one mission. Find each other. If you can do that, you're gonna split $1 million. Welcome to the matchup. 10 beams are 10 perfect matches and $1 million. Lock in.
Everyone needs to pick a different match.
This is your first shot at winning $1 million. Now all you have to do is correctly identify your perfect match. You make 10 correct choices and you win it all. But if just one person gets it wrong, you're heading back to the house to start all over again. We're gonna start with the ladies. Now girls, when I call your name, I want you to step forward and choose who your heart tells you is your perfect match. Now remember, the matchup will reveal how many couples are correct, but not who those matches are. That's up to you to figure out. Behind me are 10 beams of light. Each beam represents a perfect match. One beam is one perfect match. 10 beams, that's 10 perfect matches, and $1 million.
What an incredibly interesting math problem. Wait. I know. I said math. So the next 30 seconds are to boost my retention numbers, so hold on.
That's my girl. Be like, really? Because if that was your girl, then you'd have a little bit more respect.
Yeah, but you didn't have the balls to say that when it happened, but you want to say that now?
She just deserves better, buddy.
Oh, yeah. You gotta relax, man.
You don't have any respect, man. You
I
gotta
don't
learn
have
to
any
respect me. Hey, here's the deal. If I hear you make another derogatory comment towards a female, bro, I'm gonna put hands on you, man.
Okay, everyone, did we get that out of our system? Excellent. So let's break this down because full disclosure, it actually ends up being far more complicated than I originally thought. So strap down for some pointlessly complex discussions about a reality show with a guy like this on it.
We have this amazing experience and I just want to share it with you and just you, and I don't care what they think. They might think I'm stupid, but they don't understand what you and I have.
Speed dating. Brilliant idea. Thank you, Kayla, because everything that Kiki's saying is giving me ammo to play her and make her look like an idiot. She just doesn't get it yet. That I'm full of
At first, when I was watching through the show and had an idea of trying to solve it mathematically, I was thinking, let's dust off the old linear algebra textbook, slap this whole thing into some simple matrix, and that'll be a very simple way to show how easy it should be to find everyone's perfect match after 10 matchup ceremonies. But I made a huge miscalculation. Long story short, I was essentially treating the problem in such a way that only solved about 10% of what I was actually looking at. So I took a step back and showed this very legitimate math problem that I spent a reasonable amount of time on the respect it deserves. Now, at the risk of sounding like your 5th grade math teacher, let's start by defining the problem. So before I get into the nitty-gritty, a little disclaimer. Let me just say to anyone super familiar with the show that I'm just basing this problem off of season 1, where there's 10 men and 10 women, each with just one perfect match. Other seasons add more people and different rules that we'll just be ignoring for now. Also, I will be initially ignoring something called the truth booth that I will then be addressing at the end of the video. So stick around to the end if you'd like to know how to solve that as well. Section 1. Defining the problem. What do we know? We know that there are 10 guys and 10 girls. For ease of defining the problem, I'm going to be giving them each simple names. The men are going to be named M1, M2, etc. through 10, while the women are going to be named W1 through W10 from now on. The other things we know is that each woman has one and only one perfect match from the group of men, and obviously vice versa. That means there's exactly one solution of all the possible combinations you could make out of pairing up each one man with one woman. Speaking of combinations, with 10 men and 10 women, there would be 10 factorial, or 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is an enormous 3,628,800 ways to combine them all in a one-to-one manner. That means if you were to randomly guess each week, you would have a 1 in 3,628,800 chance of getting it correct each week, or about a 0.00003% chance each week. Fuck. Okay, we also know that we have 10 attempts to find this one solution, and of course the most important part, after each attempt we are told how many of our pairs are correct, but not which ones. Okay, on to our game plan now. Section 2, Plan of Attack. So our goal is to reach only one possible solution by week 10 so that we can be certain that on week 10 we are selecting the right groups and walking home with that big money cash prize. I believe the best way to achieve that then is to figure out how to reduce our number of possible solutions the most each week. Here's an example problem. We start with our over 3 million possibilities, and week 1 we just pick one. Let's say this one. Okay. Then when we go to the light ceremony, we get one light, which means we can eliminate every single possible solution that does not share one and exactly one couple with the one we selected. So let's do that now. Great. Now we go into week 2 and we have to select another group and repeat that step. But now it's a little bit more interesting because we have a little bit of information. Not all the solutions are going to produce the same probabilities of light numbers, as well as, more importantly, reduce our possible solutions by different amounts. And each week we are just going to get more and more information that will affect these probabilities. How can we determine which combination to pick? Well, we can take a combination and see for each light number possibility how much our solution set would reduce. We then multiply the reduced set by the probability of receiving a given number of lights. This is a concept in game theory known as an expected value, the equation of which would look like this. P0 would be the probability of getting 0 lights, and N0 would be how many potential solutions we would eliminate if we got 0 lights with that specific grouping. P1 and N1 would be the same for 1 light, and so on. So we get the expected value of every remaining possible solution and then select the one that would give us the greatest expected reduction. We then repeat this step each week. Is this not making too much sense? How about we look at a hypothetical decision tree of what I'm describing? Week 1. Again, we have no information, so we just have to pick a possible solution and go for it. Let's say we went ahead and paired up M1 with W1, M2 with W2, etc. and got 0 lights. Next week, we have removed all the possible solutions that contain any of those matchups since we know that none of them are correct. Now, from the remaining ones, we must calculate their expected value and select the best one. We then remove any of the remaining ones that would be impossible and continue on each branch. The decision tree style of problem solving is fairly common in sort of adversarial game theory problems like chess, for instance. And really what we're solving here is optimizing our play against an adversary. Our adversary in this, of course, is Brittany and Adam from season 1.
You're so into yourself.
Okay, I'm so into myself. I'm so this, I'm so that. Why are you interested in me then?
Any-
Just go away.
Any other girl in this house would not put up with your I'm not gonna lie though. They want somebody that's
Just
like Ryan that's gonna be there.
Go away.
But I am doing my own thing.
You're not doing your own thing. You're obsessed with me.
Oh my god, that's how egotistical you are. It's
Just
so
stop
up.
talking. Just stop talking to me, please.
You are so up. You have so many problems, seriously.
I tried to break up with you in a nice way. I tried to say,
Break up
hey,
with me,
I'm
we're
not
never in a
interested in you.
relationship.
I'm not interested in you. I don't want to pursue anything. We are not a match. I need another drink.
Nah, I'm just kidding. There is no adversary, but this format does still allow us to optimize our play for single player games as well. We make a move on to the next round, and then calculate our best move to optimize our play. Section 3, Execution. Okay, Now that we defined our problem and have a plan of attack, our last step is to just do it. I wrote a little Python script to do the exact thing I stated above by going through each possibility and ranking them. Then choose the best one and repeat, all while recording its results. Before we get into the results, I have one small detail to admit to. I used a simulation of 6 guys and 6 girls because I literally couldn't run a 10x10 problem without crashing my PC. Is it because my code is ridiculously inefficient? Yes it is. But hey, 6x6 is still 720 possibilities, and I took the liberty to print them all out to console if you don't believe me, so here. I'm also only giving myself 6 weeks to win instead of 10. Fair enough? So I ran this program 720 times, which would cover literally every single possibility in this scenario. I then ran a couple other simulations to compare my results to. Section 4, results. Bam! Here's the results. So with my program, we are getting our correct solution 622 out of the 720 times. Not too bad. And you can see my program is coming to the correct answer most commonly in week 6 for added dramatic effect, obviously. While this looks good, we have to compare it to a control so we can see how much better this actually performs. So for my first control, I went with a full stupid approach, where each week we just pick grouping at random and don't even keep track of what's a possible solution after each week. And then for the second control, I picked a random solution each week and only pull from possible solutions from what data we have collected from any previous weeks. So essentially doing the calculation to give us only possible results, but not attempting to pick the most optimal path necessarily. We can see a massive improvement in our success rate between the full stupid method and the method that at least keeps track of what groupings are even possible, and then a more modest improvement between the second method of tracking and my script that attempts to really optimize our problem. So does this actually help us beat this game if we were to find ourselves in an MTV reality dating show? No, not really, since we'd need to sneak a computer program onto the set, and that is presumably forbidden. However, it does shed some light on how important it is to have a group plan going into the matchup ceremony to at least ensure you are all pairing up in such a way that is theoretically still possible. Now time for me to discuss, as promised, the Truth Booth. If you are familiar with the show, you will notice I conveniently ignored this. I ignored it just for simplicity of explanation initially. The optimal strategy for the Truth Booth is actually incredibly simple. So the Truth Booth is something that occurs in between each matchup ceremony, and it's where the group is allowed to send 2 people into this booth, and it will tell them whether that one pair is a perfect match or not. The best solution for this is the exact same as the best solution for our entire group. You just calculate the expected value of each pair with the benefit of there only being 2 possible outcomes. Even easier is this actually boils down to selecting whichever pair has as close as possible to a 50-50 chance of being a perfect match. This is convenient due to the circular nature of it, in that the probability of any couple being a perfect match is directly related to how many solutions have them in it, and therefore would be reduced if they are not a perfect match, and again vice versa. Simple, right? And that about wraps it up for me. If you like to laugh, check out Are You the One on Netflix or Hulu, or any of the other terrible TV shows I mentioned. Believe it or not, I did kind of gloss over parts in the video, like my script for example, in the best interest of keeping it short and concise. If you'd like to comment on my methods or think there's areas that were questionable or need improvement, seriously, please comment on this video. I'd love to respond. Have a great rest of your day or night. Goodbye.